With the COVID pandemic posing a threat to indoor spaces, we decided to create Cleanbot. Cleanbot is an autonomous robot which uses UV light to disinfect desk surfaces. It makes use of multiple ultrasonic sensors and hosts an array of UV light LEDs at the bottom of the robot which help to sanitize the path as it is traversed. The robot is entirely autonomous and is mainly used for tables and desks. It can also avoid obstacles and edges such that it does not fall off of them. The robot is able to traverse its path using a path coverage algorithm known as booster feed-in cellular decomposition. This algorithm will divide the navigable desk surface area into different sections called cells. These cells can then be traversed individually, wherein the robot uses forward and backward motions in order to traverse each cell and disinfect that particular area. Once the UV light has disinfected that particular cell, the robot will move on to the next cell, all the while avoiding the obstacles as they are not a part of the navigable surface area. Finally, since Cleanbot will be deployed in a public setting, it will also host a hand sanitizer apparatus. This apparatus will detect motion from the hands of passerbys and will dispense a little bit of hand sanitizer such that they can use it to disinfect their hands.
So first we start off with the recursive based algorithm for obstacle detection and mapping. So here we see the robot is consistently correcting its path until it detects an edge. It backs up so that it doesn't come in contact with anything else and doesn't fall overboard. It goes to the next unit and then turns around and detects if there's an obstacle. That cell happens to be larger than the actual obstacle itself, and then it goes on to the next column and traverses its path if no obstacle is detected, which in this case there was none. And then when it detects an edge, it backs up, goes to the next row, and if it doesn't detect anything, it traverses the path, correcting its vertical axis. Detects an edge, it backs up, does the same thing again. It detects an obstacle and then goes on to the next column, but as you'll see in the next column, it still senses that there's an object. And so what it does is it goes on to the next column again, correcting its vertical path until it detects an edge, backs up, and now what it does is it tries to traverse to see if there's still an obstacle. There's an obstacle, so it fills in its graph accordingly. There's another obstacle, which is the same obstacle, continues its path, continues its path. Now it had already traversed the same path between the two obstacles, so what it does is it goes and covers the path that's behind the initial obstacle and tries to cover that, sanitizing, detecting an edge, and then eventually going back to its original starting position.
The Cleanbot also has a hand sanitizer dispenser feature. The group used the Arduino Uno kits to demonstrate these functionalities. So basically, it has three main app components. So the first one is a water pump. The water pump is a DC motor, so it is 5 volts, 71 ohm. So it needs a power supply to offer a 71 milliamperes of current based on the Ohm's law. So which Arduino pins cannot supply such a higher current. So we need to add a 9 volt battery to support this current. So the second main component is the ultrasonic sensor. The ultrasonic sensor can accurately determine the distance of the object in front. So we limit the distance to be 5 centimeters. So within 5 centimeters, the ultrasonic sensor will detect the object is in front, and then it will send a high signal to the relay, which is as a switch in this position. After it receives a high signal from the ultrasonic sensor, the switch will close, and then the power supply will support the current to the water pump, which make the water pump to run. We also have a LCD display to shows the distance that the ultrasonic sensor is detecting. We also has a red LED. It will blink when the sanitizer is working. So here, when my hands is in front of the ultrasonic sensor, it's right now at 7 centimeters. When I put it closer at 5, it starts to dispense. And after I move back, it stops. Move in. So as you can see, it has a delay of 2 seconds, which enables the user to have enough time to move out their hands, and it also avoids any visiting of the alcohol inside.